Hello, I'm the awesome tutor, and today we're looking at solving trigonometric functions in the form sine n theta plus alpha, and same thing with cosine and tan, and they're equal to a constant. Now, it's easy. All you have to do is convert all of them, instead of n theta plus alpha, just make it x. Alright? One variable. So that you're saying n theta plus alpha is equal to x. And once you solve what x is by solving the trigonometric functions, then you just put x equal to n theta plus alpha and solve for theta. Okay? But as you do that, you also have to alter your interval that they give you. So I'm going to go through an example just so you can understand. Okay, so tan 3 theta plus 25 is equal to negative 0.51. Give all the possible solutions within this interval and give all your answers to three significant figures. So our first step is we change it so that it's tan x is equal to negative 0.51, alright, where x is 3 theta plus 25. To do that, we have to change the range so it fits x as 3 theta plus 25. Right now the interval is according to theta. We need to change it so that it's for x. Alright, so we times it by 3 and we add 25. Alright, and the interval is now 3 theta plus 25, or x, is smaller than or equal to 565 and bigger than negative 245 degrees. Our second step is actually solving for tan x is equal to negative 0.51. If you don't know how to solve trigonometric equations, simple ones like these, go watch my other video on how to solve simple trigonometric functions or equations. Alright, here I use the unit circle, but really all I'm doing is just adding 180 and subtracting 180 degrees to get to the next possible value within this interval. Alright, I end up with x is equal to all these numbers to three significant figures. Now, do not round your values for x like I have done here, okay? Keep them as their full decimal, or if you're lucky, as an exact fraction or surd. Alright? The rounding comes at the end with your final answers for theta, so do not round the values for x yet, because you're still going to need to do some calculating with them. Alright, now that we've found all the solutions for x, we go to step 3. We solve for theta. We know that 3 theta plus 25 is equal to x, because we made it like that. Alright, so now we just solve for theta. Alright, we rearrange the equation, and for all values of x, you take away 25 and divide by 3. And then you round it to three significant figures, and you get the values for theta are negative 77.3 degrees, negative 17.3 degrees, 42.7 degrees, 103 degrees, and 163 degrees, all to three significant figures. Alright, now it's your turn. Okay, solve for x. Cosine 17 minus x is equal to 0.6 within this interval, and give all your solutions to three significant figures. Go. Alright, so first I alter the interval. Alright, I times it by -1 to have the interval for negative x. Remember, the inequality flips, alright, if you're timesing or dividing by a negative. And then I add 70 and you get the interval for 70 minus x, or n. Doesn't really matter what you put 70 minus x equal to, as long as you bring it down to one thing. Alright, so you could have used cosine theta is equal to 0.6, doesn't matter. Alright, so I get 70 minus 6 is smaller than 250 and bigger than or equal to negative 110. Then you solve for n, or whatever you use. Alright, and you get 53.1301 blah blah blah, and negative 53.1301 blah blah. As you can see, I use the graph, I sketch it out, but you don't really need to if you can visualize it in your head. Alright, cosine theta is the same as negative, is the same as cosine of negative theta. Alright, so you can just use that. And then you solve for x. Alright, and you get 16.9 degrees and 123 degrees to three significant figures. Alright, next. Okay, try solving for theta, where sine theta plus pi over 3 is equal to tan pi over 6 within this interval, and give all your solutions to three decimal places. So I want it in radians. Okay? Go. Okay, so tan of pi over 6 is just a value. It's one value and only one value. Don't mix it up, alright? Many different angles, alright, can be used with the tan function to get that same value, alright? But this as a whole is only one value, okay? So don't be put off that it's a trigonometric function. Just think of it as one whole value, which is root 3 over 3. Okay? So sine theta plus pi over 3 is root 3 over 3. Okay? Remember to change your calculator into radians mode. So I just make it x, alright, and alter the interval. So theta plus pi over 3 is smaller than or equal to 7 pi over 3 and bigger than or equal to pi over 3. Then I solve for x. Alright, I get my first value 0.61547 radians, which is actually not in my range. Alright, always check if the values you have are in your interval, alright, in this range. Because if they're not, you're not going to get any marks for them, or you might even lose marks. Okay, so pi over 3, what's that as a decimal, and just see if this is smaller than or equal to or bigger than it. Alright, it's smaller than it, so it's not in the range. Then I use a unit circle and find the other possible solutions, which are 2.526 and 6.898. Yeah, and then we solve for theta. Okay, and we get theta is 1.479 radians and 5.851 radians to 3 decimal places. Okay, so the only thing you need to be worried about when you see anything in the trigonometric function that is not just theta or not just x, all you have to do is make it just theta or make it just x, alter the interval, and then just solve for whatever you put that equal to, and then you solve for the actual answer. This has been the Awesome Tutor. Bye.